Hey guys, so today you and I are going to talk about tech debt. So let's get into it. So the question in question was, Frederick, is it inevitable to create tech debt in the long run? Yes, yes it is. Uh, the long and short of it is that tech debt is usually uh, even if you were to write perfect software today, it's unlikely that you will be able to predict all the things that can change within the system that you have created. And the problem with tech debt, it's a little bit of a loose term, but basically most people use it as a synonym for any code that is bad or like in the way of the thing that you want to do or unsustainable, etc., etc. And even if you write the best, most amazing system in the world, theoretically you can, and I mean, I don't want to get into semantics here because you could make an argument for that that's not really tech debt, but theoretically you could be designing a system for a specific use case and then be put into compromising situations that forces you to retrofit the very nice clean system that you have created into something that it was never really designed to do. And as soon as that business requirement changes for you, the morphing of your system is usually the problem. And when you do that, well, most developer will kind of throw up their hands in the air and say, yeah, this is not really like this is, well, I'm not saying that it's tech debt because the ugliness of the code and so forth is not necessarily something that is a direct, there's not a direct correlation between the fact that the domain changed and that then you have shitty code, but the likelihood of that happening is almost guaranteed, I would say. It's extraordinarily difficult. I would say to the point where it's impossible to never accumulate any type of tech debt because I mean, the reality of things is that when software changes and when it's especially when it's being developed by different people and the system is so large that you can't really perfectly get like an overview picture of how every piece is supposed to be working, it's almost impossible, I would say, to design it so well that no one ever raises the tech debt flag or like, we have an issue here, this is ugly, this was a compromise. Because as soon as you start compromising, which is the thing, right, when you start compromising, you lose a lot of that sensation of perfection for a lot of people. That's why a refactor, this is why these sorts of things are very subjective, because as you can imagine, in a sense it's a little bit like art or design or something like that, where if you ask an artist to compromise with their art, then by definition they have created less of a painting than they would have liked, if that makes sense. But with that said, it might turn out that that compromise later on, when they have matured their perspective, turns out to, yeah, actually they were pretty happy with it, because it's all in the beholder's eye. What is bad art? What is good art? Like, was this a good choice? Was it not a good choice? It's very difficult to say. And for technical debt, it's a very similar sort of thing, because tech debt doesn't necessarily need to mean that you have a shitty code base. It might just be that you're using old tools, or it might just be that the person who is claiming that this is tech debt has a different idea of what good code looks like. And so I would say that there is no code base where you can't claim that there is no tech debt. It's just a matter of how much have you accumulated, because the perfect system is, well, it's basically impossible to deal with. The way that I usually I actually make the argument that is my personal argument, that the number one problem of software development is to manage complexity over time, which basically translates into what I'm saying, to this thing, to handle the fact that things change. And since we are in the business of adding functionality and changing existing logic within systems, it's not that often that you don't do the product thing, because, for example, managing quote-unquote tech debt for cars or something like that, if we now omit the fact that that creates a lot of pollutions and so forth, but if we just look at it as a single entity, you don't go back and fix old cars. or like you recreate them when you want to ship a new model or new functionality. You create a new car and you sell that instead. But we software developers are in a constant stage of we are always migrating to something. Something's always moving from one thing to something else, unless we start with a greenfield project, which I mean that's also a way of that's a very nice situation if you can have that. But usually you're creating something new from something old, which may or may not have been designed to with the new functionality in mind. And that's why I'm a very big advocate of trying to have that with you at all times, to always be aware of that. You want to design your solutions in the most modular, like pluggable, or like I just like to say, create disposable code, because you never know when you need to throw something away, or you need to rewrite something, or when something new is going to be added on top of the thing that you already have, etc., etc., which is a very complicated problem usually. And that's why I like to I'm very much a conservative when it comes to over-engineering, and I usually talk with the software developers that I work with very often about this, where I like whenever we get into that space where we're starting to like trying to design something that quote unquote is a little bit nicer than the situation warrants, I try to be very careful and say, let's not go there just yet, because we don't really have an issue here. And the reason why I don't want to do this is because I don't want to create an abstraction that becomes a problem later down the road. If the abstraction that we create needs to be, in my opinion, fairly conservative. They should be well made, but we should never create like abstractions that are quote unquote just nice to have when they're not really causing us any problems. Because if we do that, it's very likely that we might lock us into some sort of like situation where it's hard for us to accommodate like future functionality, and that is how tech debt usually is made. When you have an existing thing which doesn't really fit the new use case, and now you have to retrofit it or like morph it or something like that, that's usually the way in my opinion, it starts. So what I want you to take away from this is that yeah, tech debt is basically impossible to escape. It's gonna happen if a system lives long enough, either through mistakes or through feature scope, like scope changes, or like new functionality being invented, or tools being outdated, or stuff like that. It's basically impossible, and that's why I tell people that I think that the best solution to this problem is to understand like holistically how software is developed over time, the lifespan of your code. That's why I tell like really good software developers, don't use very advanced fancy techniques or anything like that unless you're really need like certain that this is absolutely necessary, because you might not be the only person who touches this code. It might be a lot of other people that are going to do it, and any system that it doesn't matter how genius you are, as soon as it's in the hands of someone who's less skilled than you, it's over. Like then like all your technical nice solutions, they're going to fall to shit immediately. And so and for like the vast majority of people who want to over engineer and so forth, I tell them try to think in terms of what I like to call it natural resources. In other words, don't create abstractions that just like makes some arbitrary thing a little bit simpler. Try to keep yourself as low level as possible, as with as few lock-ins as possible, and as little like fluff as possible, because the problem is never to add. Adding is always easy. It's always easier to add things than it is to remove or change existing things. And that's why you should be very conservative with accumulating more dependencies or more abstractions or things like that. And if you're adding abstractions, make sure that you, at least that's how I think about it, create disposable code. Create things in layers, pluggable layers, where you can you can take like functionality that is there today and plug it into some interface that does something, or you can add other interfaces on top, etc., etc. But don't create a situation where things are, it's so tightly coupled that it has to work this way. Because when you get into the tight coupling problem, that's usually when you have to make very hacky compromises, and legacy just starts from there usually. Have a great day.